My name is Wolfgang Kinzelbach. I'm a professor emeritus of ETH in Zurich, and my field was hydrodynamics and groundwater. My first experience and the way I learned to cherish groundwater was in Africa. In the 1970s, I was a lecturer in northern Nigeria, and this is a tropical environment with a lot of air, waterborne disease, and still we had beautiful, safe and cool water to drink, which came from a deep borehole. That is how I learned to love groundwater. But this was in the 1980s when in Germany we found for the first time the chlorinated hydrocarbons in groundwater. And I was in the first German project of cleaning up chlorinated hydrocarbon spill. And out of it came guidelines for how to treat this kind of pollution. This was the way I entered the field of groundwater. What I'm most interested in is this notion of sustainable use of groundwater. And there are many cases or instances of non-sustainable use of groundwater in this world. And one of the major ones is the overexploitation of groundwater reservoir. Out of the 1,000 cubic kilometers which we pump every year, about 1/4 is not replenished, it's not sustainable. And one of the hotspots is the North China Plain, where I used to work for 6-7 years. The problem is agriculture. Especially winter wheat grows in a period when you have no rain, so it is completely irrigated by groundwater. And that is the main culprit. So in the last 50 years, groundwater levels have gone down considerably. And this has consequences like seawater intrusion at the coast, soil subsidence under the cities, no more flow into rivers because the groundwater table is below the riverbeds. And also when groundwater tables are deep, you spend more energy to get groundwater up. So China wants to change that. And it's a rather difficult task. First of all, how do you know how much overpumping is going on? There's about 1 million wells in the region, and you cannot monitor everyone by going there and measuring groundwater levels. That's impossible. But there's one advantage. No matter how primitive the wells are, they are all energized by electricity. So the pumps work electrically, and electricity is paid for, so it has to be measured. So we have nowadays automatic smart electricity meters which report energy use once a day, so we know the energy use. Now all we need is the conversion factor, and we did this in a county of the North China Plain, that for the wells we found a regionally different conversion factor to calculate how many cubic meters correspond to the kilowatt hours used. So that's the first step to know how much you pump. Then you can start to reduce. Well, in general, one must say the North China Plains agriculture is not in equilibrium with its renewable water resources. So we need less agricultural production, or we have to bring in water from somewhere else. And both ways are chosen by the Chinese government. There is the South-North Water Transfer Scheme, which brings water into North China Plain. And this water is replacing all those water users who can pay for the water, like industry, households. Another measure which is taken is to give subsidies to not plant winter wheat, to fallow the winter wheat fields. And this, of course, will also save water and has the potential to bring down the water use. Water-saving irrigation has too little potential to really be of importance. And of course, if you give somebody money to keep a field fallow, you have to check whether he really is doing it. And we used remote sensing, both optical and, because there is also clouds or haze, the radar images to find out what is growing in a field. I think we were quite successful in doing the monitoring, both of winter wheat growth and of water abstracted. There are several items. Number one is, of course, we always have new pollutants. So I started out with chlorinated hydrocarbons, and we had the nitrate, we had pesticides, and nowadays we are worrying about the PFAS or the forever chemicals. So that's a new type of pollutant, and new ones are coming. We have to look into this and what we can do about it. So with climate change, we have the spring droughts. And in the spring droughts, we need more irrigation. And if we need more irrigation in the future, maybe it will not be as terrible a situation as the North China Plain, but we will have problems with sustainable use of groundwater. A third item also has to do with climate change. We want to decarbonize our energy supply. One way of doing it is to use heat pumps which take heat from the shallow underground, also from aquifers. Now this is of course an opportunity and also a risk. A risk because if we go into groundwater we may pollute it, so we have to take care of that. And also we would not like to change the temperature too much. With climate getting warmer, we have hot summers, we need much more cooling than we did before. Now we could just turn around the heat pump and say in summer we pump the water which has been cooled down by extracting heat in winter. Now if we can balance these two, then we are in a very good situation. Actually, we do this at the Höngerberg campus of ETH Zurich, where we extract heat in winter and we store cool in summer. But the ratio is not yet favorable because it's 1 to 3. With climate change, this ratio becomes more favorable to have this balance where heat goes in and out of the underground. Well, groundwater is an old science, and as such, it doesn't have a steep learning curve. If you really want to have science which is developing fast, you have to go into different fields. But it doesn't mean that I recommend you not to do hydrogeology. What is growing is the problems which you have to solve with the methods of hydrogeology. So I think if you are willing to be more applied and to really solve problems for people, then groundwater is still a very good field for you.